Our next participant is Ana Maria Medina Ramirez, a Faculty of Engineering and Computer Science. She's doing Masters in Mechanical Engineering. Her thesis title is Production of Aluminum Nickel Foams by PM route using dolomite as a foaming agent. And the title for today's talk is Production of Metal Foams using dolomite.
Have you thought how safe you are in your car? In an accident, do you know how well your car will protect you? The materials world has improved in terms of ergonomics, finishing, and style. But what about safety? The evolution of safe materials has been slow in the last 10 years. Why? Unfortunately, safe materials are expensive to manufacture. My research focuses in looking for a low-cost solution to this problem. My objective was to create a material with the ability to absorb large amounts of energy and resist strong impacts, and I found it. I have created a porous material with those specific characteristics. Let me give you a mental picture of how this material looks like and works. When you have a baguette, what do you see? You see bubbles. You see a foamy structure, just like a sponge. Now imagine the bread made of metal, aluminum, for instance. You will have a multiple pore structure. The chemical reaction between metal powders creates an expansion, the same reaction that baking soda has in the bread, having as a final product a metal foam, a metal sponge. In this case, the baking soda is what makes the metal foams costly. During my investigation, I came out with a new recipe. I used dolomite, a natural mineral which reduces up to 75% of the total production cost and increases 50% of the stability of the process. My fan and foams are very light materials, and the distribution of the pores creates an internal network. If I crush my foams, all the energy received from the impact gets trapped and dispersed in the solid connection. It's like matching a cracker and a baguette on the same time. All the energy will produce that the cracker will break, while the baguette will just tend to stabilize itself after the impact. And that's exactly what we want a car to do, to resist any shock. In the world, around 1.3 million people die from car accidents. On average, 3,200 deaths per day from the impact. Here is where safety conditions are crucial to preserve humans' life. If my research contributes to the evolution of safety materials, I could be saving my family's life and yours as well. Thank you very much.